Alright, welcome to the chapter where we're going to be simplifying radicals. In this case, we're going to be just simplifying radical expressions, which means we're not going to have any equal signs, and we're just going to be reducing radicals to the lowest form. The best thing to do is to make sure that you know your perfect squares. So your perfect squares would be a 1, 4, 9, 16, 25, on and on. What a perfect square means is 1 is equal to a 1 squared, 4 is equal to a 2 squared, 9 is equal to a 3 squared, and then 4 squared, and on and on and on. These are helpful. I guess you don't have to know them, but it does help if you can find perfect squares underneath your radicand. Alright, so what we're going to start off with is simplifying some radical expressions. You can see 1 through 6 here. We're going to do most of these. This is where we're going to simplify the number that is underneath the square root. Looking through these 6, only one of them is a perfect square, so only one of them is going to end up without a square root in your answer. So let's look at number 1. 20. 20 is not a perfect square, so that means we're going to need to reduce it. So the way you can reduce this is the easiest way to do it would be by doing what we call a factor tree. So if you have an even number, what we're going to do is we're going to divide that number by 2. Left over, 20 divided by 2 would be a 10. Now 2 can't be reduced any further, but the 10 can. That's an even number, so you can divide that by 2, which is going to be 2 times 5. The 2 can't be reduced any further. Now the 5 can't either. Now what you may notice is we have a pair of 2's over here that are on the branches of our factor tree. For every pair of any number you have, you bring that number outside your radical. So we're going to have a 2 on the outside. You only bring it out once because you're finding pairs. And then if you have a 5, this 5 is left all by itself. It doesn't have anybody to pair up with. It stays underneath your radical. So what we have done is we have now simplified our radical expression. And it cannot be reduced any further. Let's try the same thing here on number 2. For number 2, 52 is not a perfect square, so we will just split this up. Now this is a 2, or sorry, it's an even number, so it can be divided by 2. So we have 2 times 26. 2 can't be reduced any further. 26, however, is even, so we have 2 times 13. And 13 can't be reduced any further because it is a prime number. So we look at our grouping again. We have a group of 2's. So we take that 2 out. Left all by itself is your 13, so he is going to stay underneath, he or she, sorry, he's going to stay underneath your radical. So you get a 2 radical 13 when you simplify radical 52. Now let's try 72. 72 looks like it could be a possible perfect square, but it's not quite. So we're going to divide this by 2. So 2 times 36. Now you could do 8 and 9 also. Okay, so actually let's do that. I always like to divide by 2 or 3 or 5 at the beginning if I can, but let's start off with maybe an 8 and a 9. I'll show you how you can do this differently. So 8 times 9, because that's what a lot of people know, multiply to give us 72. So the 8 can reduce further. That can become a 4 times a 2. And your 9 can be reduced further. That can be a 3 times a 3. Your 4 can be reduced further into a 2 times a 2. This 2 can't be reduced further. This 3 can't be reduced further, and this 3 can't be reduced further. Now the reason I don't like it this way is because on the left side we always have, or an example of 1 and 2, we always have these numbers that can't be reduced. They're always on the outside. Here we do have a pair of 2's. We can either group these 2 together, or group those 2 together, or group this 2 and this 2. I just don't like it that well. I think it's a little more not as organized. So, and then your 3's are over here also. I like to have everything going down a nice straight line whenever I can try to find its pair. So we will leave it like this, so just for you. So there's a pair of 2's. So we're going to bring a 2 out. Now we have a pair of 3's. So we're going to bring that 3 out, but we're going to multiply it by our 2 that's already out there. And then this 2 is all by its lonesome, so he's going to stay underneath our radical. So on the outside, you have to multiply any pairs together. So 2 times 3 gives us a 6, and a 6 radical 2. So So I guess I could box my answers in here. There's that one, 6 rack 2, there you go. All right, let's try just a couple more. 27, that's an odd number, so, and it's not a perfect square, so it's an odd number, so you can't divide by 2, but let's divide by 3. So 3 times 9 gives you 27. 3 can't reduce. 9 can become a 3 times a 3. So we have pairs of 3s. Actually, we have 3 3s. Doesn't matter which 2 you pair up, but you're going to have one left over. So we're going to have a 3 radical 3. And then finally, let's do number 5. Here with number 5, we can split this up. Well, this, actually 100, this is where it's helpful to know your perfect squares. 100 is actually a perfect square. So this answer, you just get a 10. And that is your final solution. That's how you simplify radical expressions.